Here's an application example on exponential functions. It says based on data from the past 50 years, the world population in billions can be approximated by the function, where x equals 0 corresponds to 1950. Letter A says estimate the world population in the year 2015. So if x is equal to 0 means 1950, that means x equals to 1 is 1951, x equal to 2 is 1952, and so on. What x will correspond to 2015 so that I can use that x value and evaluate this function? What we do is we take 2015 and we subtract 1950 from it, and that gives us 65. So when x is equal to 65, that represents the year 2015. So I found my x, and this is what I do. Now I can try and estimate the world population in the year 2015. g of x is equal to 2.5 times 1.0185 to the x power. Now I'm going to evaluate this function for the value 65, which is the year 2015. And you do this in your calculator. What you do is you input this number first, and then you raise this number to the 65th power. How do you do that? In your calculator, you have a symbol that looks like an upside down V. That is your symbol to raise to the power of 65. And once you have that answer, you multiply by 2.5 and you will get 8.23. And that means 8.23 billion people would be the world population in the year 2015. That's the estimate. Okay, and now letter B says, in what year will the population be double what it is in the year 2015? In what year will it be double? Double means this population, which is the estimate we found for 2015. So twice. When will it be twice what it is in 2015? This is 16.46. So what it's asking is, when will the function equal 16.46 billion people? This is what it's asking. And the year we can find if we find that x value. So basically we're solving this backwards, and to do that we need logarithms, and we will learn how to do that later on. For now, we're going to find the answer with the graph. And that graph we're going to use WZ Grapher, and I will show you in a moment. Here's the function we were talking about, world population. This is what the graph looks like. And we had done letter A, finding what was the estimate of the population at the year 2015. And the year 2015, we had said that was our x equal to 65 value. So in between 60 and 80 here, I can find 65. There's 65. You see the cursor. When I move the cursor, it gives me the coordinates. So I can go up to my graph, and at x equals 65 right here, my y value is 8.2. And remember, we had calculated 8.23. So this is pretty accurate. Now the letter B question was, when will I have not 8.23 billion people? When will I have double that? When will I have 16 billion people? So 16 is between 0 and 20. I'm going to zoom in a little bit so that this range in the y-axis, notice as I zoom in, here's 15. So we're talking about 16.46. So let's go to our graph and see where is y equal to 16.46, or very close. There it is. But it has to be on my graph. So there, 16 right there, and it's at 102.49, more or less, right? It's pretty close. It's at about 102 there, 102.88. So at y equal 102.88, I have 16 point, at x equal 102.88, y is equal to 16. So for your x of 102, we can estimate that to 103. Okay, so at x equal 103, that's where I'll have double the population I had in 2015. Now we have to figure out what 102, what year that is. So if x is 102, I have to find out what year that is. Let's go back to our PowerPoint presentation so we can calculate that, okay? We saw in our graph that for letter B, I will have 16.46 billion people on Earth when x is equal to approximately 103. Now we need to know what year this is. So if x equals 0 is 1950, x equal 103 is what year? So that means I would have to add 103 years to 1950. And that gives us the year 2053. In the year 2053, the population will be double what it will be in the year 2015, okay? That's how you do it using your graph. I hope this example helps. Have fun with this. If not, go back, okay, and watch it again and try it on your own. I'll see you in the next video on applications.